Okay, so let's go now for this last problem, which is a problem similar to something that we solved already in chapter 18, one of the assignments, which is the story of the importance of having a current very small if I want to have small losses. So what is the idea? Let's see. Um, we have an average of 120 kilowatts, so 120 watts of electric power that is generated somewhere in a power plant. Okay, so the power that is generated, the amount of energy per time that this power plant generates is 120,000 watts. Okay, and we want to send this energy, want to send this power to a small town which is 10 kilometers away from our power plant. Okay, in the transmission lines we will have losses, and because the transmission lines have some resistance. Now over those 10 kilometers it accumulates a resistance of, they are saying here, 0.4 ohms. No? So it's small, given that we have 10 kilometers of distance, but it's still a number that will cause losses. Very well. Then comes the question, calculate the power that is lost if the power, if the energy is transmitted at 240 volts or if it's transmitted at 24,000 volts. Okay, so the power generated is this, and this is not going to change. But with transformer, I can increase or decrease the voltage. Okay, so this power generated, so let's put it here, this power generated is equal to IV, right? Um, if my voltage, if I'm going to have the transmission and if my voltage is 240, what is the current that I will have transmitted through the lines? Well, we can use this equation. The current is going to be the power over the voltage. So that's what you're seeing here. The power generated doesn't change, but if the voltage over the voltage we have control by using transformer. So if the voltage is just 240, if you put this here, you're going to get that the current is 500 amps. Okay, so this is part A. For 240 volts, the current is 500 amps. For part B, I use the same equation. So I use now a transformer that is a step up. That is going to give us 24,000 volts. So if I put here this 24,000 volts, if I put here this 24,000 volts, I'll get a current that is much smaller. It's just 5 amps. Okay, so in this case, I started with small voltage. For this case, is if instead I have a large voltage, I have a small current. How about the losses? How do we get to the loss? We are going to use this equation, power, now power dissipated, power that is going to be lost, is equal to I squared multiplied by R. So if you use this equation, you will see that for 500 amps, you dissipate a lot, 100,000 watts. But if you use a very large potential difference, so you have this tiny current, the loss is going to be just 10 watts. So that's the importance of having a step up before transmitting. So that's the purpose of what we were talking before in this slide. Right when we leave the power plant, use a step up to have a very large potential difference that will guarantee that the current is very small, so we'll have small losses along these very long transmission lines. And that's now the end of our problems.